Hello everyone, hope you are safe and sound. In our previous session, we started learning trends in the modern periodic table, in which we were learning atomic size. What it is? The term atomic size that refers to the radius of an atom. And what is radius of an atom? It is the distance between the center of nucleus and the outermost shell of an atom. I have already told you that the atomic radius is measured in the unit picometer. The atomic radius of hydrogen atom is 37 picometer, where 1 picometer is equal to 10 raised to minus 12 meter. Now let us study the variation of atomic size in a group and in a period. Here, atomic radii of the elements of the second period are given. So as you can see, the elements and their atomic radius. Now we will arrange this atomic radii of the elements in decreasing order. Then we will get the numbers like this. What do we observe? When we arrange atomic radii in decreasing order, then we will observe that the elements are arranged exactly in the order how they are in second period. First is lithium, then second is beryllium, then boron, carbon, nitrogen, oxygen. And what about their atomic radii? The atomic radius decreases as we move from left to right in a period. So this is the property of the elements related to atomic radius. This you need to keep in mind. By this activity, we can see that the atomic radius decreases when we move from left to right in a period. Why atomic radius decreases while moving left to right in a period? This is because there is increase in nuclear charge, and that tends to pull the electron closer to the nucleus, and that is why it reduces the size of the atom. What does this mean? This means as we move from left to right in a period, we know that the atomic number also increases. So, as atomic number increases, the number of valence electrons are also increases, and these electrons are pulled closer to the nucleus, and that reduces the size of the atom, and that is why the radius of the atom decreases. Now let us study variations in the atomic radii in the group. Here are the atomic radii of the elements. They are of group 1 and they are not arranged. So when we arrange in increasing order, then we will get the numbers like this. And if you observe that these are the elements arranged in group 1: lithium, sodium, potassium, rubidium, cesium, and they are in increasing order of atomic radius. So from this we can say that as we move top to bottom, then the atomic radius increases. Students, these two things you need to remember. Moving from left to right in a period decreases atomic radius, and moving top to down atomic radius increases. You will be thinking, why atomic radius increasing moving from top to down? Then the reason is, we know that in each group number of shells are added, new shells are added, right? We have learned that they have valence electrons same. The electrons in outermost orbit will be same for elements in same group, but they do not have same number of shells. So for each element in the group, shells are newly added. And when shells are added, we can easily understand that the distance between the nucleus and the outermost electron will be increasing. If new shells are increasing, then the distance between nucleus and the outermost electron will be increases. And this means that the atomic radius and atomic size increases. So now we need to remember that atomic size decreases moving from left to right in a period, and atomic size increases moving from top to down in a group. Now let us talk about metallic and non-metallic properties of the elements. When we were learning about the modern periodic table, in the introduction only, I have said you that the left hand side elements are metals, the right hand side are non-metals, and in between zigzag line, that elements are metalloids, which means they are semi-metals. So as we can see that the metals like sodium, magnesium are on the left hand side of the periodic table, and non-metals like sulfur and chlorine, they are on the right hand side. Here I have taken only two names, but we can say that all the non-metals are on the right hand side of the periodic table. In the middle we have the silicon, which is a semi-metal, or else we can say it as metalloids. Why it is called metalloids or semi-metal? Because these elements possess properties of both metals as well as non-metals. We know that in the modern periodic table, a zigzag line separates metals from the non-metals. And the borderline elements, which are they? Boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. These are said as metalloids or semi-metals because these elements possess properties of metals also and non-metals also. Now, in chapter 3, we have learned that metals lose electron, will give electron while forming bonds. That is why they are called as electropositive in nature. So here is a new term for you. Let us understand it. Two terms will understand: electropositivity and electronegativity. What is electropositivity? The ability to donate electrons and to form positive ions is called electropositivity. Ability to donate electrons which means to give away electrons. And we know whenever the atoms give electrons, then they form which ion? Positive ion, right? What is electronegativity? Ability to gain electrons and to form negative ions. So this is the difference between electropositivity and electronegativity. Okay, when atoms give electrons, donate electrons, they form positive ion. Okay, so from word only we will remember this: electropositivity. Positive means positive ion. When can an atom gain positive ion? When they give electrons. Electronegativity, negativity. From this we can remember negative ion. When can atoms gain negative ion? When they take electrons, when they gain electrons. Okay, so these are two different terms which we need to remember. So as I said you, metals give away electrons, they lose electrons, they donate electrons. So by giving away electrons, they became positive ions, and that is why metals are electropositive in nature. Metals possess electropositivity. That is why we can say that metals are electropositive in nature. And the non-metals are electronegative in nature. Take an example of chlorine. We know chlorine is a non-metal and it gains electron. So by gaining electron, it becomes negative ion. So non-metals are electronegative in nature. Okay, so these two things you will remember: property of metals and non-metals. Metals are electropositive in nature, while non-metals are electronegative in nature. Metallic character decreases across a period and increases down a group. As we know that moving from left to right, slowly the metals on the left hand side, metals are present, right? Then the semi metals and then the non metals. So we can see that moving from left to right in a period, metallic character decreases. Metals are becoming semi metals and then non metals, whereas metallic character increasing, moving from top to down in a group. Okay, so this thing we will remember. So from this we learned that metals are electropositive in nature, whereas non-metals are electronegative in nature. And this property help us to understand, to predict the nature of oxides which are formed by the elements, because we know that the oxides of metals are basic in nature and oxides of non-metals are acidic in nature. So this is all about trends in the modern periodic table.